going to discuss on what will happen if a 350 kilogram cow ate 35 kilogram of feed grade urea. So before we discuss, I would like to introduce myself. My name is Najwa Atika and my group members. This is Faizatul, Faiz, and then Fakri, Aziz, Amila, Cheryl, Arina, Anis, and also the one who's holding the camera, Anur. So we're going to start our discussion now.
Hi everyone, so I'm going to talk about the composition of feed grade urea. Do you know what is feed grade urea? You don't know, right? So feed grade urea is actually a solid white trail with an even round shape. It is a non-protein nitrogen compound that can be used as a supplement to the diets of ruminants across a range of feed strategies. The nutritive value, the protein is a major limiting nutrient for the current animal production. For the product properties, physical properties, approximately there are total nitrogen urate equivalent crude protein, moisture bulk density loose, ISO 3944, bulk density tap ISO 5311, size guide number minimum of 46% and maximum 1.2% with a minimum 287.5% and maximum 0.5%, which is 730 gram per liter and 755 gram per liter. Okay, the nutritive value, the protein is a major limiting nutrient for the current animal production. The feed grade urea is a non-protein nitrogen source for ruminants. The microbes in the rumen metabolize NPN or non-protein nitrogen compounds to produce ammonia and use this ammonia for microbial protein synthesis that will be available for absorption through the gastrointestinal tract of the ruminant. The feed grade urea has a typical value of 287.5% equivalent crude protein for ruminant. So I'm done with my part. I'm going to pass to Aziz. I'm going to pass to the one who is going to talk about what is crude protein.
To explain more about the what is crude protein. So protein is very good to our health. Okay, it may involve in the immune function, oxygen transport, and maintaining the strong muscle tissues. So the crude protein is a measure how much protein is in food based on the laboratory tests studying the food's chemical composition. So when we look for protein content on the food's nutrition level, it is actually show you the number of how much the crude protein is. So the crude protein content is sometimes used as a standard of quality for dogs and cats food. So the protein in pet food sometimes comes from grains and the sweepings from the slaughterhouse floors, as well as other meat sources considered not fit to human consumption. In animal feeds, the crude protein is calculated as a mineral nitrogen times 6.25 is the assumption of the protein. Typical animal feeds contain 16% nitrogen in average. The mineral value obtained by the Geldal method or method that giving similar result after correction, such as Dumas method. Okay, I will pass to Faiz to explain about the digestive system.
Okay, as we all know that cow is a ruminant animal. What is ruminant animal? Ruminant animal is the animal that have 4 chambers. Each of the chamber have a microbe that can digest or break down fiber that contain in a grass or roughage. Okay, the 4 chamber are the rumen, reticulum, omasum, and abomasum. I would like to explain two of the chamber, rumen and reticulum. What is rumen? Rumen is the largest of four compartments and is divided into several sacs. So, what is the function? The function of the rumen is act as a storage or holding bed for feed and fermentation bed. This is because the rumen has a very large compartment. The rumen also can absorb most of the volatile fatty acid produced from fermentation of feedstuff by rumen microbes, and enhanced by a good blood supply to the walls of the rumen. Tiny projection called papillae increase the surface area and the absorption capacity of the rumen. Second is reticulum. Reticulum is pouch-like structure in the forward area of the body cavity. Reticulum placed near the heart of the animal. The tissue are arranged in a network resembling a honeycomb. Heavy or dense feed and metal objects eaten by the cow drop into this compartment. So for the omasum and abomasum, I would like Anne to explain more about this.
Now I will continue cow's digestive system, which are omasum, abomasum, small intestine, large intestine, and cecum. Okay, for omasum, this globe-shaped structure contains leaf of tissues. The omasum absorb water and other substances from digestive contents. Feed material between the leaves will be drier than that found in the other compartments. Next, abomasum. Abomasum, this is the only compartment, also called the true stomach, with a glandular lining, hydrochloric acid, and digestive enzyme needed for the breakdown of feeds are secreted into the abomasum. The abomasum is comparable to the stomach of the non-ruminant. Next, small intestine. The small intestine measures about 20 times the length of the animal. It is composed of three sections, which are the duodenum, jejunum, and ileum. The small intestine receives the secretion of the pancreas and the gallbladder, which aid digestion. Most of the digestive process is completed here, and many nutrients are absorbed through the villi into the blood and lymphatic system. For the large intestine, this is the last segment of the tract through which undigested feedstuff pass. Some bacterial digestion of undigested feed occurs, but absorption of water is the primary digestive activity occurring in the large intestine. And for the last one is cecum. The cecum is the large area located at the junction of the small and large intestine, where some previously undigested fiber may be broken down. The exact significance of the cecum has not been established. That's all from me. Next, I would like to ask Najwa about the protein metabolism.
Of the cow, enzymes from bacteria will specifically urease break down urea to carbon dioxide and ammonia. Ruminant bacteria have the capacity to hydrolyze or break down up to 1 gram of urea per liter, about a quart per hour, with diets high in urea. The ammonia, which is liberated from urea, is utilized in one of the two ways. Part of the ammonia is ingested by the bacteria and is incorporated within the cell to form bacterial protein, which is later digested by the cow. This bacterial protein accounts for a very significant portion of the protein actually absorbed and used by the cow to acquire its protein diets. The remaining ammonia is absorbed directly into the rumen wall, where it enters the blood. Then it is carried to the liver, where it will be transformed back as urea. Excretion is the predominant means by which excess blood ammonia levels are handled and eliminated. Consistent availability supply of energy is required. for both the breakdown of urea and its incorporation into microbial protein. This energy is derived from the breakdown of other feedstuffs within the rumen. So when feeding, urea is desirable to utilize a readily fermentable source of energy such as processed grain or molasses. Urea can only be utilized with the energy present from readily available feed sources in the rumen. Specifically, the ruminal bacteria must have a source of carbohydrates, which is starch, with which to combine the nitrogen obtained from the breakdown of urea molecule in order to form bacterial protein. So urea metabolism cannot utilize animal stores of energy such as fat tissue from within the cow itself. So it is important to recognize the usefulness of urea or NPN, as well as the limitations in the formulation of feeds and rations. So now I'm going to let Anis to explain more about the protein metabolism.
So I'll continue about the protein metabolism in the ruminants. The protein consumed by the cow has three phases. First, fermentation in the reticular rumen by ruminal microbes. Secondly, enzymatic hydrolysis in the small intestine. And lastly, excretion of indigestible protein in feces. First, I'll talk about the ruminal protein degradation. Rumen microbes, especially bacteria, degrade most of the dietary protein entering the rumen. However, some of the protein will escape ruminal degradation, which we call RUP. Some of the RUP will be digested in small intestine by proteolytic enzyme produced in the pancreas protein, and some of it will be excreted in feces. The end product of dietary protein degradation in the rumen is ammonia and microbial protein. The end product of digestion of RUP and microbial protein in the small intestine is amino acid. Two major steps are involved in protein degradation in the rumen. First, hydrolysis of peptide bonds to produce peptide amino acids. Secondly, deamination and degradation of amino acids. Protein hydrolysis is a multi-step process. Insoluble protein is solubilized and then hydrolyzed by a variety of endo and exopeptidases which cleave the peptide bonds. The hydrolysis of peptides occurs extracellularly by proteolytic enzyme associated with the bacterial cell wall. Many of the protease enzymes produced by the rumen microbes are trypsin-like in nature, suggesting that proteolytic activities in the rumen can be reduced by trypsin inhibitors. Free peptides and amino acids are absorbed rapidly by rumen microbes and used as such or deaminated. Non-structural carbohydrate bacteria utilize peptides and amino acids as end sources. Next, deamination. Metabolism of amino acid is the next step in protein degradation by rumen microbes. The main end product of amino acid deamination is ammonia. An important byproduct of amino acid deamination is branch change VFA, which enhances the growth of cellulolytic bacteria. Ammonia produced from deamination of amino acid is used by structural carbohydrate bacteria used as a nitrogen source. So next, I'll pass to Faizatu to continue to talk about the protein metabolism.
Good.
Okay, so I will continue about the protein, what happened to the cow when they feed grade urea. First of all, I want to explain that most feed urea is mixed into commercially distributed concentrate feed for growing or lactating dairy cows, which means we cannot directly give the animal feed grade urea. We must mix them with other concentrate feeds. And second, from my finding, cattle weighing more than 350 kg should be fed at a level not more than 0.3 to 0.5 kg of the mixtures containing more than 80% of cooked protein, which is the cooked protein we can get from the urea, with a high urea content. As we know, feed grade urea has a very high urea content. And what will happen in the rumen of the cow, the urea will be broken down rapidly by the urease enzyme into ammonia. and then the process will combine with the microbial synthesis, which is from ammonia, to enable the ruminant to utilize the urea that entering their rumen. And next, and a cow, for cattle, it is okay for them to take diet that is low in nitrogen because urea in their blood will be recycled back for their use. And next I will continue about ammonia assimilation. First step, ammonia uptake will be transported into the cell membrane, across the cell membrane. And second, glutamate is the first amino acid that will be used when the assimilation process started. And the last one, excess ammonia is converted to the urea in the liver, and the urea will be excreted through urine. Okay, that's all from me. Thank you. So I have finished my part, so I will give it to Arina to continue.
Okay, I will explain about our protein digestion in the small intestine. The nitrogen entering the duodenum is a combination of microbial protein, undivided protein, and endogenous protein. Nitrogen entering the small intestine from the stomach can range from 30 to 100% microbial protein and 0 to 70% undegraded protein. Digestion of protein in the abomasum and the small intestine in ruminant is similar to that in monogastric animal. The digestion of protein in the abomasum is carried out mainly by the pepsin in very acidic environment, which is pH 2. Slow neutralization of digestion in the upper part of the small intestine expand the activity of the pepsin but delay the onset of the intestinal enzyme activities. Optimal activity of trypsin, chymotrypsin, and carboxyl peptidase does not occur until the middle jejunum, and peak activity of exopeptidase and dipeptidase is found in the mid-ileum. A unique characteristic to ruminant is the evident expression of pancreatic ribonuclease. An important role of this enzyme is to release nucleic acid phosphorus for recycling in the rumen via saliva. Okay, next I will explain about the absorption of amino acid and peptide. Okay, the most episode of amino acid and peptide absorption is the mid to lower ileum. There is a preferential absorption of essential over non-essential amino acid from digestion flowing through the small intestine. Differences in absorption also occur within the two groups of amino acid. For example, absorption of lysine and histidine is higher than the absorption of leucine and phenylalanine. Okay, that's all from me. I will pass to Minda and Julie to explain about the effect of feed-grade urea.
Thank you, Arina. For cattle to use urea, microorganisms in the rumen must be able to convert ammonia released from the urea into microbial protein. Urea is highly soluble in rumen, and microorganisms rapidly decompose it to ammonia and carbon dioxide. The ammonia released from urea can go to two pathways. It can be made into microbial protein, or it can also build up and be absorbed through the rumen wall into the bloodstream, which carries it to the liver, where it is detoxified and excreted in the urine. In this case, the cow consumes urea about 10% from the ration. Thus, ammonia toxicity will happen. The liver detoxifies ammonia by converting it to urea to be excreted in the urine. Some of the urea is recycled to the rumen. However, through saliva and by absorption from the blood through the rumen wall. However, if ammonia escapes the rumen too rapidly, the capacity of the liver is exceeded and ammonia spills into the main blood system. High levels of ammonia circulating in the blood can cause toxicity or even death. This suggests that if urea is to be an effective source of true protein for cattle, conditions in the rumen must be favorable for microorganisms to use the ammonia from urea before it escapes into the rumen. Whenever ammonia is overflowing in the rumen and bacteria already have sufficient ammonia for metabolism, additional urea in the ration is of no value or in meeting the protein needs of the cattle. So the amount of urea that can be used by the rumen microorganism will depend upon the number of microbes and how rapidly they are growing and whether ammonia and other essential nutrients are available when needed. Furthermore, the microbes need vitamins, minerals and a readily available source of energy for fast growth. Therefore, more ammonia can be used when high energy feeds are fed. Cattle fed high grain finishing rations can make better use of the urea in their ration than cattle feed low energy rations. Next, shall we continue the effect of feed grade urea to the cow?
So I will continue to explain about the effect of excess consumption of urea in cattle, in the cow. When the urea is excess, the consumption of urea is excess, and subsequently release of ammonia into the rumen exceeds the rumen microbe ability to digest it and convert it to the bacterial protein, the ammonia concentration in the rumen will increase. This will cause an increase in pH of the rumen. This increase in the alkalinity of the rumen's contents then facilitate the passage of ammonia through the rumen wall. When this happens, the excess ammonia will absorb into the bloodstream. This increases the alkalinity in the bloodstream, and it is the most important factor that contributing to high blood ammonia concentration and related toxicity in animal consuming urea. This increase in blood ammonia concentration can exist the liver capability to process the ammonia back to urea for recycling in the salivary gland or the body ability to excrete it through the urine. Concentration of ammonia nitrogen approximating 2 to 4 mg per deciliter of blood are generally associated with urea-induced death. However, the chance of toxicity has been found to be high when blood ammonia concentration is exceed 8 mg deciliter in 60 minutes following urea consumption. As in number of normal physiological process include normal cellular metabolism process and increased uptake of ammonia by brain and an upset of central nervous system. Although no well-defined, the cause of death in ammonia toxicity appear to be respiratory arrest. You will note that it is ammonia toxicity that creates problem and not the urea itself. That's all. Thank you.
Based on our discussion, I can conclude that the cow will undergo ammonia toxicity and will eventually die. So that's all from our discussion. Thank you.
Bye. Bye.
Bye.
Last discussion.